All right. Hi, guys. Today we are talking about pure substances, and specifically, we are talking about compounds. So, compounds are super common, they're everywhere. The water you drink, they're in the air that you breathe. We couldn't live without compounds. So, we're going to find out what makes a compound a pure substance and what makes it different than an element. So, if we're looking at the big picture, chemists classify matter based on characteristics, and we can classify matter either as pure substances or mixtures. We're starting over here on the left with pure substances. So, there's two types: elements and compounds. I know you guys are pretty familiar with elements. You find them on the periodic table. If I look at these little diagrams, particle diagrams of elements over here on the left, I've got these red spheres that represent a type of element, and I have blue spheres, and I can see that, oh, okay, well, they're all the same color. That makes sense. I can see how that's pure. But if I look at a compound, I'm noticing that I've got green and purple together. So how is it pure if it's got two different colored spheres going on? So that's what we're going to find out about. So first of all, what is a pure substance? Well, it's a substance with definite physical and chemical properties. So if I picked an element off the periodic table, I could list its properties. They're always true for gold. Gold is malleable. I could say gold's melting point. What does gold react with? Those are definitive properties. Compounds also have definitive properties. Water is a compound. Water has a specific boiling point, 100 degrees Celsius. It has a specific freezing point, 0 degrees Celsius. Those are definitive properties of those pure substances. Now, I think this bullet point is maybe even more important. A pure substance is made up of just one type of particle. So that's really important. So again, if we look at these pictures on the slide, we have helium atoms, oxygen molecules, and then I have a picture of a water molecule. I have red and blue together. How did they get together, and what does that mean? Sorry, I went backwards. There we go. All right. So again, here's some particle diagrams, and these particle diagrams, we're going to look at more of these and practice looking at them. But again, you can just tell by the colors. Up with the elements in each box, just one color. That makes sense. One type of particle. In the compound box, all those little particles are the same, but they're made up of two different colored spheres. So let's talk more about that. Elements are called elements because they're made up of one type of atom. If I have a brick of gold, that brick of gold contains only gold atoms. Compounds are made up of one type of molecule. So even though it's two or more types of elements, something's happened that they've combined chemically, and it's one type of molecule that makes up that compound. So let's look at an example together. Well, this is super important, obviously, if I have a giant important stamp on the slide, that the elements combine chemically to form a brand new substance with new properties. I'm going to say that one more time. In a compound, elements combine chemically. They're not just mixed together to form a new substance with new properties. So let's talk about salt. Sodium chloride. It's one of the most abundant compounds on Earth. Sodium and chlorine, the elements that make up sodium chloride, are really super reactive, super dangerous elements. How does it become something we put on our French fries? The element sodium is a soft, silvery metal. You could cut it with a butter knife. And if you put it in water, it catches on fire. It's super reactive. We'll do that as a demo in a couple of weeks. Chlorine is a poisonous reactive gas. In World War I, it was used to kill people. It's horribly toxic and nasty stuff. So again, how does a flammable metal and a green poisonous gas become what we put on French fries? Well, it happens through a chemical reaction. So if I have, for example, in this little video, I have a flask of green chlorine gas. If I put a little pellet of sodium in that flask, they react, chemical reaction, chemical change, and a new substance is formed. The inside of the flask is coated with white sodium chloride, what you do put on your French fries. That chemical change has bonded the sodium and the chlorine together to form something brand new. Brand new with new properties, nothing like the original sodium and the original chlorine. And so we call this new substance sodium chloride. And